Okay, so thank you for joining tonight. And we have two speakers. It is Josh and Saul. And the third person that actually organized the meetup cannot be here tonight, Reinhard. Thank you very much. And tonight, Josh and Saul will talk to us about serverless teams and the best practices around it, and then observability excellence on AWS, of course. So, Josh, you can take it away and start. Thank you very much.
Sure thing. Cool. Yeah, so I'll get started and run through my presentation. Should just be a quick one, and then Sol will take over. We're sort of both focusing on optimizing or empowering sort of serverless workloads. So sort of a similar theme. And you might notice our slide decks are very similar. And yeah, that's essentially because we're from the same company. So we're both from a company called AWS, which is a consultancy based in London. We also have a team in Cape Town, and that's where I currently am now. So I'm working out of Cape Town, currently in the process of moving here, which I was telling the guys earlier. And I guess like a brief intro to me is I'm a cloud architect at AWS. So a bit more sort of information is, you may have gathered this by sort of the titles, but we mostly work in AWS and on serverless workloads. So I'll get into serverless. I'm sure Sol will sort of cover that as well. But yeah, we're basically helping to migrate large companies or startups to AWS using a serverless workload. We typically use a serverless first approach. If you guys know what that is, but not too important right now. And yeah, I've got a QR code there if you want to connect to me on LinkedIn. Always looking for connections. Always looking for that networking. You know how it is. So feel free to scan that and connect to me. And yeah, if you want to have any chats off this talk, feel free to let me know, etc., etc. Cool. So sort of to introduce my talk, I'm going to be talking about empowering serverless teams and sort of enforcing best practices while still maintaining developer velocity. So just a brief sort of explanation into what serverless is, so you guys sort of aren't confused. The sort of presentation today is not going to hinge on knowing what serverless is, so that doesn't matter too much if you're not too sure. And I'm sure Sol will give a better explanation than me later on. So if you're not too sure, don't worry. But essentially, when we talk about serverless, we're talking about a variety of services. You can see some here. So API Gateway, Lambda, DynamoDB. And what makes these services serverless is various sort of factors, most notably some of them being like pay-per-use. So if I make an invocation to Lambda, Lambda will spin up and spin down, and I'm only paid for how long Lambda is running that invocation. So if your website's not getting any traffic, if you're not using any computes, then you're not billed for that. Whereas if you're using something like EC2, that's sort of a long-running server where you will be billed over time, regardless of use. Another nice thing is sort of scalability and elasticity. So compute will scale up and down. So if you're getting 1,000 users one day and then 1 million the next, just chucking numbers out there, then your compute will scale up and down to meet those numbers. And you don't typically have to worry about that. There's some sort of configurations you can do to help scalability. We're not going to go into that here, but for the most part, AWS will manage that for you. And sort of as a whole, these services are what we call managed. So when you're using something like Lambda or DynamoDB, you don't have to worry about the underlying operating system or like patching it. AWS manages that for you. If no one sort of used serverless, I encourage you to go to AWS console and look at something like DynamoDB or Lambda, and you sort of be surprised at the lack of configuration that is required, and it's really easy to get going with these services. So really nice if you're sort of a startup getting used to AWS, or maybe you want to reduce sort of your total cost of ownership. A lot of that's sort of handed over to AWS. And I guess, yeah, this diagram here, this is just a really simple diagram that'll show you sort of hitting an API and then writing something to a database. So DynamoDB is your database option there. Cool. So once I've covered serverless, serverless isn't just about the services. You also need to sort of, it's a different way of working. So on the left here, you can see like a traditional team. And in this traditional team, you might have various experts. So you might have a security expert, an infrastructure expert, et cetera, and they all sort of manage different parts of the application. When it comes to serverless, as I mentioned, AWS manages a lot of things for you. So when we try and structure serverless teams, and this is typically what we do at Alios, we'll have a team, but there's no sort of distinct owners, I suppose. Everyone is sort of empowered to own the full application, whether that's like the security, stuff about the database. Every sort of engineer effectively can just work on every part of the application. So this is sort of what we encourage engineers to do. It works well, and because of AWS managing everything for you, it is something you are able to do, which is really nice. And yeah, I guess like a really nice thing about serverless, which possibly is good to mention, is it encourages you to own just the business logic. So rather than worrying about the operating system of my database or this or that, or oh, what's the network security or something like this, you can really just focus on that business logic and pushing value for your company. So those are some things we start to see serverless teams are able to do. And because of that, they can move a lot faster, and they can produce more effective workloads for the most part. Cool. This really sounds great, but you know, everything's not amazing. So what are the problems with this? Because yeah, there are a few. You know, everything's not sunshine and rainbows. So possibly one of the, I guess, issues with this is, although I can own the whole stack as a serverless engineer, there's potentially a chance that some resources might be misconfigured, just because I'm owning such a large sort of range of services within the application. This data is taken from Trend Micro, and it's not applicable to just serverless workloads. I believe this is all workloads within AWS. What we can see here is sort of the services and sort of the misconfiguration percentages. And I guess a misconfiguration is sort of a configuration that a team, you know, didn't mean to do, or is causing like some issues in their account. So yeah, you've got some here, CloudFormation. It seems it's quite highly misconfigured. I mean, that makes sense because you're building other resources with CloudFormation. So maybe you would expect that. And yeah, you can see a bunch of resources here that are misconfigured. Scarily, IAM is quite highly misconfigured. You can see CloudTrail there as well. So yeah, this is not something we want. We don't want resources misconfigured. And potentially this is an issue with serverless workloads. We might see these misconfigured percentages go up. Just some sort of data on why we don't want this. I'm sure if you go into your browser now and type in S3 bucket leaks or anything like this, you'll see a load of articles about how someone has made their S3 bucket public. And this has led to, you know, sensitive data being leaked, customer data, which, as you can imagine, is not ideal for your organization. It's going to cost you a lot of money, potentially even, you know, bankrupt you. So really avoiding these misconfigurations is ideal. This is obviously sort of an extreme case, but this is just sort of to paint the picture for you. Cool. So yeah, we obviously see this problem potentially these resources might be misconfigured. We don't want this to happen. It could lead to sort of really bad ramifications for our business. So how do we improve the process? If you've worked with AWS a bit, I mean, there's many ways you could maybe look to improve this. I've just put in a selection of services or resources here that maybe you could use. Some of them being service control policies within AWS organizations. So if you have a development team, they're expecting to provision certain resources. Maybe you have a development team and you only expect them to work with Lambda, API Gateway, and DynamoDB. You can create what we call a service control policy, which only lets them provision those resources within their account. Also put service catalog here, which is sort of, I guess, like a wrapper on top of CloudFormation. In that, you can go to serverless catalog and then build out some or provision some predefined templates that your business has built for you. So again, sort of rather than provisioning services yourself, you go to serverless catalog and use these templates to build resources. Not ideal, especially when we're talking about serverless teams. You're really restricting the team on what they can do. And when it comes to serverless, we don't want to do this. We want to empower the teams as much as possible. So we don't really want to impose too many restrictions on them. Things like service control policies are good, but sort of rather than being extremely restrictive, maybe want to let the team have some freedom on what they're doing. I've also put in to the right here, you'll see Chekhov and what is this other one? I can't quite see. Oh, Sneak. These are services we've used in the past, Chekhov and Sneak. We can sort of integrate them in the CI/CD pipeline. They're third-party services. And what they'll do is they'll check for like misconfigurations, open S3 buckets, security risks, things like this. So you can integrate them in your CI/CD pipeline. This is really nice, and I really encourage anyone to look into these tools if they're using infrastructure as code, CI/CD for their AWS workloads. For me, these aren't a complete solution though. There's still some issues with them, most notably being that they only check at the CI/CD level, whereas working with AWS, there's many ways you can provision a resource. You know, you can go directly into the console. You can get another service to provision a resource. So you can have a resource provisioning a resource, and many other ways of doing it, I'm sure. So although it's great, it's sort of only stopping one sort of barrier to provisioning resources. Oh, wrong one. So I guess what I like to use, rather than these solutions, or at least you can use these solutions, but they're not going to solve every issue for you. But yeah, what we've used in the past and what I quite like is AWS Config. So this is a huge service that AWS loves pushing. And I'm sure if you've done a certification or read into AWS, you've heard of this service. But essentially what it is AWS Config, once enabled, will keep a historical record of sort of all your resources within your accounts. And you can create what's known as these rules, and they essentially evaluate your resources against these rules. I guess just as like a concrete example, you might have a rule for checking if an S3 bucket is public. And if you then provision an S3 bucket that is public, it will then flag this for you. You can see like the severity here. Actually, I think this is a screenshot from Security Hub, but it uses config for this dashboard that it's got here. And yeah, it will tell you if that resource is misconfigured, et cetera, et cetera. One important thing to mention here is config does flag resources if they're misconfigured, but one thing that you got to be careful about is it won't take any actions by default on those resources, on those, or when it's flagged. You've got to create those actions yourself. So, for example, I've got quite a nice little architecture diagram here. If you want to be notified of when, I don't know, a resource is misconfigured. So here I've got the S3 buckets example. You'll need to integrate config with SNS. So to sort of go through this example, let's say we have an AWS engineer and they make a bucket public. That'll be recorded in config. Config will probably flag that as public. But then at this point, if this is where our architecture diagram ends, nothing else will happen. You'll just be able to go in the config console and see that it's flagged as non-compliant. So what is recommended is you integrate config with some other service like SNS. So if we integrate with SNS, this will then enable us to notify an AWS admin who can then say, hey, why are you making that public, that bucket public? Or maybe they'll go in and manually change it themselves. So it's a very powerful tool, but just be aware that you usually have to integrate it with another service. So notifying is cool, and probably where you might, you'll probably use SNS in most cases when you're working with config or some sort of notifying workflow. One thing I quite like though, you can have a look at, which is nice, is actually remedy the issue. So what we've got here is a very similar setup to that previous slide. You have the AWS engineer who's making the bucket public, and then there's configuration change, which is recorded in the config. And what we've got here is systems manager. If anyone's used parameter store or patch manager or anything like that, that's systems manager, but it also has an automation workflow part to it as well. And that automation workflow part has a set of like runbooks. And what these runbooks do, they're like defined by AWS, and they'll perform certain changes on your accounts. So the runbook I've got in this example would be a runbook to make that S3 bucket non-public. So to go through the flow again, the AWS engineer will make the bucket public. That'll be recorded in config. It'll then be recorded as non-compliant, and we can integrate config with systems manager to then trigger a runbook that will then remove the public access on that bucket. And yeah, I guess this is something you want for a critical vulnerability or something you really don't want to happen into your AWS account. So then you can sort of automatically fix the issue as soon as it happens. Cool. Now, I'd quite like to show you config in action, and this is definitely the part where things might break. So let's pray that it doesn't happen. So I've got config in the console here. And what I've done is I've just kicked off a deploy. So I'm just going to change some resources in the background. But while that's happening, you can see a few things here. I only really want to look at the compliance status section here. So you can see I've got a compliant rule. This is for, it's kind of hard to see, but that S3 buckets public rule we've been talking about through this presentation. So this AWS rule will detect if an S3 bucket is public. Go back to that dashboard. Oh. I can also see free compliant resources. So in this AWS account I'm sharing with you, I have deployed free S3 buckets, which are all non-public. One of them is like a CDK thing. So these are not accessible via the internet, which is all nice. And config has flagged that for us, and it says compliance. So this is all perfect. How was my, okay. And what I've also got is a, so this is in Systems Manager. and sort of the automation section of Systems Manager. So this is the automation documents that I was showing you or going through earlier. So if I go back, so this is, yeah, essentially hooked into config. I've got some code which integrates these two services. Maybe I can see on integrations. No, maybe not. But what you can see here is that it's got the runbook, which will disable S3 bucket public read write. So if I deploy a public S3 bucket, it should then record this in config, and then the runbook will run and it will disable that public access. I did run this earlier, so you can see, I'm not sure when that was, a couple of hours ago maybe, but you can see that this execution happened a couple of hours ago. It was a success, and all this execution did was it disabled the public access on a bucket. I would like to show this in action, but I've been checking my deploy and it's taking quite a long time, so maybe another time. But yeah, in this Systems Manager run, you can quite see where it started and ended. It's pretty quick, and it's quite nice to integrate config with this service, and it's really nice and easy to do so. Cool. Yeah, there's a ton of other things here. You can see conformance packs and things like this. I don't think I have time to go through all of those, but I do have some sort of considerations that maybe you might need to take when working with config. So yeah, I mentioned conformance packs. The conformance packs are essentially a set of config rules. So one thing I quite like is they have like a serverless conformance pack. And what this has is it's a pack which contains rules like, you know, can't add public access to an S3 bucket, ensuring your Lambda, I don't know, I'm just making these off the top of my head, but doesn't have like a ridiculous timeout, or that it doesn't have like a old runtime. So it's just a set of rules within a single thing, and you can deploy these conformance packs as one. And these are all provided by AWS. And so if you just Google conformance packs, you'll find a ton. And yeah, you can find one that maybe will suit your workload. Another thing we've realized when working with config is pricing. I sort of mentioned at the start that AWS loves pushing config, or at least us to use config, and that's because it's very expensive. So they love AWS users using it because it absolutely, you know, causes their bill to skyrocket. So just be very careful when working with config. It can be quite expensive. Make sure you're not, you know, recording every resource, or maybe only a selection of resources. It's also quite expensive in development environments, because if you're continuously pushing resources in your development environment, then config is going to record sort of an entry for every resource, and that's going to kind of build up. I went over the rules very briefly. So AWS provides rules that we saw, but you can also create custom rules. So I'm not too sure, but if you wanted, I don't know, your S3 buckets to have a certain name or follow a certain pattern, you could create a rule for that. And that essentially uses Lambda under the hood. So you write the code in Lambda, config triggers that Lambda and then receives a result. And that's how it evaluates the compliance of the resource. I've also already been over conformance packs. Yeah, again, be careful between automatic remediation versus sort of notifying an admin. Automatic remediation is really cool. The only issue is, you know, if I'm working and I push a resource and suddenly it changes without me knowing, that's probably going to cause annoying sort of issues for me if I don't know that config is changing things in the background. So just be aware of that. Also highly encourage that you manage config and sort of rules and all this through infrastructure as code. There is, well, you can start building out a ton of rules and all this, and it can really add up and be really difficult to manage sort of by yourself. So I really recommend using infrastructure as code. Cool. That's the end of my talk. I put in my Medium link there. I'm plugging everything today. But that essentially will take you to an article which goes over this in more depth. So if you want to know a bit more, I had to rush towards the end there because of the time. But yeah, if you want to read more about this, feel free to follow that link. And if anyone has any questions, feel free to. And you can ask any questions on serverless or AWS. Maybe not any AWS. I'm not knowledgeable of every service, but anything that's serverless or config or what we've been over, feel free.
Josh, can you paste that link into the chat as well?
Sure thing, yeah.
Later. Yeah. Hello.
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 Good.
Hey, how's it, Josh?
Good.
I'm also from Cape Town, by the way, but I'm living in Pretoria right now.
Nice.
Maybe this is kind of like more of a background thing or prerequisite thing because I'm kind of new at this, but like what would serverless teams need to know about IAM before they're creating an application? Like, let's say an example, like you built something that you want to now sell and hand over. Like, I don't want to give them my AWS account to access the DB and all that stuff. Like, how do I catch myself up there?
So are you saying you're trying to give access to your AWS account to someone else, or?
I built something and then I sold it and then I want to hand it over. How do I do that? What do I need to know? What are the warning things before I go building, setting up my infrastructure and everything like that?
Okay, yeah. What do you mean by selling it? As in, you're handing over your AWS account, or?
Oh, that's literally the application that I've built. I don't know if I'm making proper sense there. Like,
No. I think it's making sense. I mean, if you want to give anyone sort of access to your AWS account, whether that's like temporary or anything like this, AWS recommends you create an IAM role, and then I'm not sure if this is answering your question, and then the third party that you're given access to will be able to use that IAM role to access the AWS account. And the really nice thing is you can associate permissions to the IAM role. So you can say, I only want them to access this or this or this. I'm not sure if that's answering your question, but
yeah, it's getting there. Are the resources all on AWS to catch up on that, or I don't know if you have maybe something to point me to?
Oops, sorry, is that another?
I just like suggest to maybe Google it a bit and see what's out there. But when you do give them access with this IAM personal role, like just make sure to like restrict what they can do with this IAM policies, and also put an IAM permission boundary if they do have IAM permissions, because otherwise they can give themselves more permission, and they don't want that. So it's a bit complex. I would say do a bit of research, and then maybe reach out to one of us a bit later, and we can give you some more advice.
Okay, cool. And I know I guess the question was a little out of scope. Sorry for that, but that was a great presentation. Thanks for that.
Not at all, thank you. Yeah, just pasted something there that might be useful. But yeah, make sure you giving access to anything that you don't want these people accessing. That's kind of the key there. Yeah, sorry, go ahead. Whoever's next in the queue. Can't quite see.
Hi there. Lovely presentation, Josh. I wanted to ask around the pricing issue of AWS Config. Is there a way perhaps to use lambdas as part of your flow to sort of get around what AWS Config actually does?
I mean, potentially. Off the top of my head, I don't actually, maybe not. I don't think that there's any way to detect if a resource is being provisioned in your account. Maybe someone else knows, but as far as I'm concerned, config is the only way to detect if a resource is being provisioned. Maybe you can integrate something with EventBridge. But off the top of my head, yeah, config is all I can think of. Sort of on the pricing though, it's not too expensive if you manage it. It's just very easy to fall down the rabbit hole of activating everything that config possibly will enable you to activate, and then not looking at the budget or not setting budget alarms. And then one day you wake up and you've got a huge bill. So it's a great service, and I wouldn't sort of let the pricing deter you. Just be aware, maybe set budget alarms, and just make sure you're not configuring it on every resource that you need or anything like that. But in terms of getting around it with Lambda, I'm not too sure. I would also encourage, I mean, I'm a bit biased because I love managed services, but I would encourage you to use the managed services provided by AWS. So I wouldn't try and recreate something that's been created before. But yeah, I'm not too sure. I would think config is the only way to do this.
Yeah, like I also have just do that quickly. Like when you do provision some of these config rules, like they have two options to like run once a day, or and then you have some that's immediate, like the one of that public S3 bucket will probably be like an immediate one, but that reads CloudTrail, so there's like a 50-minute delay sometimes. But that one gets read more often, so you'll pay more. And don't use all of the rules inside a conformance pack. Like only the ones that you really want to use, because otherwise it scans a lot, and then you pay for it. So I think you only pay for when you scan, right, Josh?
Yeah, exactly. Yeah, there's a ton more things about config I didn't mention, so I really encourage you to go have a look at this. This is more sort of an introduction to it. But yeah, if you have time, really sort of have a deep dive into config in your own time. It's a really cool service, and there's yeah, as I mentioned, tons of things I didn't go over.
I think in consideration of time, let's keep the other questions until the end. Just make sure that you make a note of them, or you can paste them in the chat if you don't want to lose them. And thank you, Josh. I think let's hand over to Saul.
Thanks very much. I'll just share my screen. Okay, hopefully you guys can see that. So yeah, first of all, thanks very much to everyone for taking the time out of the day to attend this talk. And thanks again to Rayhan and Reinhardt for organizing the meetup. So for my talk, we're going to be looking at mastering observability in AWS with X-Ray and CloudWatch for specifically serverless architectures. We're mainly going to focus on X-Ray, but I also wanted to touch a bit on CloudWatch to talk about how those services can sort of complement each other. So I'm Sol. I'm a serverless developer at Alios, which Josh has already sort of given a bit of an intro to. But basically, as he said, we specialize in helping startups to innovate and enable the enterprises to stay competitive by leveraging cloud native and serverless technologies. So just a quick overview of what we're going to go through today. We're going to start with a quick serverless overview. Obviously, Josh has sort of touched on that a bit already. Then we're going to look at some of the observability challenges presented by serverless. We're going to do a bit of an intro to X-Ray, talk about how it can help with some of those challenges. We're going to move on to how you can set X-Ray up and configure it. And then we're going to go into a bit more detail with things like tracing and sampling, service maps, segments and subsegments, and how we can use it to identify issues. And then we're going to look a little bit at CloudWatch logs and how we can use that in combination with X-Ray. And then we're going to do a short live demo debugging a simple serverless app using X-Ray and CloudWatch. And we're just going to wrap things up with a conclusion and Q&A. So just to start with, I thought I'd start with AWS's definition of what serverless is. So they've said that a serverless architecture is a way to build and run applications and services without having to manage infrastructure. So basically what this means is that AWS is going to handle server management and allow us to focus on business logic and code. Some of the key characteristics that we might see from serverless architectures include stateless compute services. So functions are going to run independently, and each invocation of these is going to be isolated. We're also going to see automatic scaling. It's going to scale based on demand, and there's no need for manual intervention for this. And we're also going to have event-driven execution. So this means our functions are going to be triggered by specific events. So these are going to be real-time actions like HTTP requests or, for example, database changes. So now that we've aligned a bit on what serverless is and its key characteristics, let's dive into one of the main operational challenges, ensuring effective observability in such distributed and stateless environments. So in serverless, we're going to have highly distributed components, and it can be quite hard to trace requests across these independent services. And tracking the interactions and dependencies between the services can be complex. There are also no traditional servers. We don't have access to the physical servers or the operating systems running on them, which means that traditional monitoring tools and methods might not be as applicable. We've got ephemeral functions, which means that the functions are temporary and terminate quickly, and that can mean that continuous tracking and maintaining context across invocations is difficult. We've got stateless operations, which means that each function invocation is independent and has no memory of the previous calls, which can make it challenging to follow the state or context of requests through multiple steps in a flow. Event-driven triggers also mean that functions triggered by events can span multiple services, and this can complicate understanding and debugging of how events flow and interact. So next, let's see how AWS X-Ray can address some of these challenges and improve observability in serverless environments. So I'll start with the definition of X-Ray from AWS. So they said that AWS X-Ray is a service that collects data about your requests that your application serves, provides tools that you can use to view, filter, and gain insight into that data to identify issues and opportunities for optimization. So X-Ray is going to provide end-to-end tracing, and what this means is that it's going to track the entire journey of a request as it flows across our various services. This is going to help us understand how the requests flow through different components. It also provides centralized insights. It brings together log data and trace information in one interface, and it simplifies the process of diagnosing issues by integrating these various data sources. It's also going to provide invocation data. It's going to capture detailed data from each of our separate function invocations automatically, and it's going to provide visibility into function performance and errors without the need for extra configuration. It also offers contextual details to understand these stateless executions and helps in piecing together information from short-lived independent functions. Finally, it also visualizes how different services and events interact and provides a clear map of event-driven processes to aid in debugging and optimization. With understanding of how X-Ray addresses these challenges, let's explore how to set up X-Ray for your serverless applications and start leveraging some of its features. So setting up X-Ray might be a little bit different dependent on the services that you're using, but it's always like super straightforward. It's pretty much just going to be like a Boolean flag or similar. In terms of API gateway, you might want to enable active tracing for each stage in your API. And this is basically going to allow X-Ray to track the entire lifecycle of API requests and responses. And it's going to give visibility into how those requests are processed and handled. I say active tracing because it has something called passive tracing by default, which basically means that any request that it receives, essentially from other AWS services that are already traced, it will continue to trace those anyway. So that's enabled by default, but you also might want active tracing to sort of start the tracing with your API gateway. In terms of Lambda, this one's even more simple. If you're doing it in the console, you can literally just go to the Lambda functions page, go to the monitoring and observability tab, and just enable X-Ray. But when you're doing this with Lambda, you also want to think about instrumenting your actual application code with the AWS X-Ray SDK. And this is basically going to allow us to provide more detailed trace data and custom instrumentation, which is going to help us capture specific metrics and context within our code. Once we've done this, we can access the X-Ray console to view the service maps and the trace details. And the console is going to provide a visual representation of our request flow across the services. And it's going to provide detailed information to help us diagnose and optimize performance. So now that we've covered some setup, let's dive into how X-Ray handles tracing and sampling. We're going to look at how it's going to capture detailed trace data while managing overhead and the default behaviors for a couple of the services. So as we've said, X-Ray is going to track requests as they move through our services. It's going to provide a comprehensive view of how the requests are processed from start to finish. It's going to capture important details such as timing, metadata, and any errors encountered along the way, which is going to help us understand performance and behavior of our application in detail. So now we come across the concept of sampling. So maybe instead of tracing every single request that comes through our system, we only want to trace a certain percentage of these. And we can set up custom sampling rates to do this. And it's going to be really useful when we want to optimize for costs. So for example, you might have a really busy production environment where you only want to trace, say, like 5 or 10% of your requests. But maybe in your development environments, you want to trace all your requests so that you can debug and optimize effectively. In terms of default behaviors, Lambda is going to, by default, trace 1 request per second and then 5% of any additional requests that come through. And this one for Lambda specifically is actually a fixed rate. But similarly to what I was saying earlier, for the default of API Gateway, it also has passive tracing so that like any requests that reach your Lambda that are already traced, it will continue to trace them as well. And then similarly to Lambda, API Gateway has that same default rate, but you can actually adjust that percentage to fit your needs. X-Ray has like a really minimal performance impact and balances data collection and operational efficiency pretty well. In terms of Lambda, the X-Ray daemons are already pre-installed on a Lambda container, so it's not really going to affect your bundle size. And it's going to buffer the data and write it in batches to reduce the processing and memory overheads. In terms of the memory usage, it's going to use 3% of your Lambda's memory or 16 megabytes, whichever of those two is greater. So now that we understand tracing and sampling, let's see how X-Ray's service map can visualize the traces and help us understand how services interact and where potential issues may lie. So X-Ray is going to create this visual map of our services and their interactions, and it's going to provide an overview of how the different services communicate with each other. We can see how requests flow through various parts of our architecture, and it's going to help us understand the end-to-end journey of the requests and potentially identify some bottlenecks. The nodes are going to indicate issues with their colored outlines. So you might see a red outline for 500 series errors or a yellow outline for 400 series errors. You can see a couple of those on the nodes in the service map on the screen now. The one that you don't see is that you'd also see purple outlines for throttling issues. Another thing that's not particularly obvious from this nodes here is that the actual size of the nodes represents the number of requests that flow through that part of your architecture. We can use this to set up for a deep dive, and the service map can help us focus on specific areas where we're going to find latency issues or errors. We can drill down into the individual traces and identify and troubleshoot performance problems. So to better understand this service map, let's talk about the building blocks that it actually uses. And these are segments and subsegments. And these elements provide the detailed view that we need for diagnosing specific issues within serverless applications. So what are segments? Segments represent the major components or services in our architecture, for example, API Gateway, Lambda, DynamoDB. And each segment is going to give a high-level view of a service's role in handling a request. Segments provide insights into the overall performance of each major service, and they help us identify which service might be causing bottlenecks or contributing most to latency. Subsegments are the smaller parts of segments that represent individual operations or steps within a service, and they are a more granular view of what's happening inside each service, such as specific execution steps, database queries, API calls, and that sort of thing. Subsegments provide detailed insights into the actions performed by a service, making it easier to pinpoint exactly where issues like delays or errors are occurring. These are useful for understanding more fine-grained interactions within a service beyond what segments alone would show. So what you can actually see on the screenshot here as well is a segments timeline that you can see in the X-ray console. And this is basically going to depict like each of our different subsegments and how much they're going to contribute to the overall latency of our request, as well as some like status and response code information as well. So now that we understand what segments and subsegments are, let's see how we can use this detailed information to identify and address latency issues and errors in our serverless architectures. So let's imagine that you notice that part of your application is running slower than expected. Common scenario here might be due to a slow DynamoDB query, for example. We can use X-ray to examine the segments and subsegments and look at the timing data for each subsegment to identify where the delay is happening. And this can help us to pinpoint that specifically that DynamoDB operation that's causing the latency. We can also use this to pinpoint errors. So errors might occur when requests pass through multiple services, such as from API gateway to Lambda into a database. And identifying the exact point of failure in such a flow can be challenging. By examining the error flags that X-ray provides on subsegments, we can find exactly where the failure occurred. While X-ray provides powerful tracing and error detection, we can use it alongside CloudWatch to further enhance observability. Let's look at how CloudWatch logs can complement X-ray to provide even deeper insight. So we're going to have two sort of key types of logs in CloudWatch. The first of which would be automatic logging. So CloudWatch is going to automatically log essential information such as invocation details and any errors that occurred during a Lambda's execution. And this is going to provide a quick way to get basic insights into the function's behavior without any additional setup. We're also going to have custom logging. So developers can use inbuilt loggers like console log in JavaScript, for example, or structured logging libraries to capture specific details or debug information. And this allows for more tailored insights, capturing exactly what we need from each function execution. The setup for this is super simple. CloudWatch is enabled by default for Lambda. For some other services, it might need to be enabled manually, and you might need to provide a CloudWatch log group, but it's always really easy. And once you've done that, the logs can be easily accessed and analyzed using the CloudWatch console and provide a sort of centralized place to monitor all of our logs. Some of the benefits we'll see from this is that with CloudWatch logs, we can view our execution details and performance metrics immediately after the function runs. And this real-time feedback is valuable for monitoring and optimizing application performance. CloudWatch is going to help us quickly identify and diagnose issues by logging errors as they occur. And if we combine this with X-ray, we can get both high-level trace data and detailed execution logs. So now that we've covered CloudWatch logs and how they can enhance observability, let's talk about integrating these with X-ray to provide a more complete view and streamline our troubleshooting. So by linking CloudWatch logs with X-ray traces, you can get a richer context for what's happening in your application. And this integration allows us to correlate trace data with specific log entries and provide a complete view of each request. So logs often contain error messages and debug details that might not be captured in the traces alone. Combining these with trace data is going to give us deeper insight into application behavior and issues. X-ray is going to assign a unique trace ID to each request, which can then be used to link to related log entries. And the trace ID can act as a sort of bridge, which is going to help us match logs with the corresponding traces. And when an issue is identified in a trace, we can use the trace ID to find those related log entries. And that's going to help us understand the context and details of what went wrong and make troubleshooting more efficient. So the benefits we'll see from this is a more complete view. We're going to be able to integrate CloudWatch logs and X-ray to provide a holistic view of both performance and errors. And this complete perspective is going to be crucial for maintaining reliable and efficient serverless applications. We're also going to see more efficient debugging. because combining the insights from both logs and traces can make it easier to pinpoint the root cause of our issues. And developers will be able to quickly move from identifying a problem to understanding and then resolving it. So next, we're going to look at a sort of simple and quick demo of like debugging a serverless application. We're going to look at an application which is going to fetch a random fact from a public API. It's going to store it as a JSON file in an S3 bucket. So this is like a super simple architecture just for the sake of looking at traces. So what we're going to see happen here is a request is made to the API gateway, which is going to then invoke a Lambda function. The Lambda function is then going to fetch a random fact using Axios and upload it to the S3 bucket as a JSON file. And all the while, X-Ray is going to capture the traces in the flow and provide insights and error tracking. And the Lambda logs will also be sent to a CloudWatch log group. Now I'm just going to hop over to present the Lambda code. Hopefully you guys can see VS Code now. So what we're going to see here is that we're using Axios. Oh, sorry.
It's still frozen.
Oh, of course.
Is it just stop presenting and try again?
Yeah. Is it better now?
Yeah.
Awesome. Thank you. So yeah, as you can see, we're now in our actual Lambda handler code. This is in JavaScript. And we are going to use Axios here to make a GET request to this third-party API. And then we're just going to do some sort of simple validation and error handling, which we don't have to sort of worry too much about for today. And then we're going to use the SDK to upload that JSON file into an S3 bucket. And then we're just going to return a success or failure response. But in terms of X-Ray, the things that we're actually going to focus on here are that we're going to use the AWS X-Ray SDK's capture HTTPS global to make sure we're capturing all of our Axios requests, which is going to include this GET request here. And then we also want to use this capture AWS v3 client method to capture the SDK calls that we make to upload that object into S3. So now I'm just going to hop over to Postman. I'm going to make a request to an API gateway that I deployed earlier. Hopefully we'll get a 200 here, and we're going to get that fact uploaded successfully response. And if we actually expand this and we have a look at some of the response headers that we get, we'll notice that we've got this trace ID here. And I can use this trace ID. If I copy that.
I think it's frozen again, I think.
Is that better?
Yeah, that's good. Yeah.
Thank you. Sorry about that. Okay, so now if I hop over to the X-Ray console, so now I'm just in the X-Ray console. This is actually now a part of CloudWatch as well, but we're in the X-Ray traces tab. And then I can just paste that value that I got from my trace, from my response header even. And this is going to bring up first the sort of trace map, and we can see the request as it flowed through all the different parts of our architecture. You can see that it hit API gateway, invoked our Lambda. It's got this separate Lambda context node, but this is actually just one Lambda function. And then it's going to make the call out to this third-party API. And we've got this because we use that capture HTTPS global method. And then it's going to make the SDK call to put that JSON file in the bucket. So hopefully we'll also see that in our bucket, we do have our new fact, which is that fires on land generally move faster uphill than downhill. Nice. So also on this trace detail here, if we scroll down a bit, we're going to see the segments timeline, which is similar to the screenshot that we saw earlier. And we can actually see like how long our requests spent in each different part of our service. And we can see on the left here, it's broken down by the different AWS services involved. But then also it's got the subsegments within those to show like the different actions within that service. And also at the bottom here, we actually have aggregated logs. Sometimes it takes a little while for these to come through though. Hopefully if I refresh, maybe not. But essentially what you'd actually have here is the CloudWatch log group data for this request. I'm not sure why it's not appearing now, but sometimes CloudWatch does just take a minute to get the logs through. We won't worry about that today. But essentially what you'd see there is actually the log statements that we've got throughout our application code, and they would appear aggregated at the bottom there. So this is what it would look like for a successful call, but how would we actually see a failure? So this is one that I did earlier with a bad API key for that third party. And what we can actually see here is that the API gateway node is in red because a 500 series error was given to the client. And if we actually dive deeper into this, we can see that the third-party API node is in yellow because it gave a 400 series error in response. And if we go down here, similarly, we can see the segments will also show the faults as well as the response code in this column here. And yeah, now you can actually also see what I was talking about, where we have the aggregated CloudWatch logs as well. And then here you can also see the error that was logged out here. So we could also use that to sort of diagnose the problem. So now I'm going to jump back to the slides if I can. Nice. So we've seen how we can build a simple serverless application using Lambda, API Gateway, and S3, and how we can then use X-Ray to help us trace and debug the application effectively. We use the random fact API to fetch a fact and store it as a JSON file in S3. Some of the benefits that we saw from using X-Ray here was quick identification of any issues. We had end-to-end visibility into the request flows, and we had simplified debugging and monitoring. So just to round off with some of the key takeaways, AWS X-Ray provides end-to-end tracing that helps us visualize and understand the flow of data across our serverless components. Using X-Ray in conjunction with CloudWatch logs can help us build a full picture of application performance and errors. And using both X-Ray and CloudWatch, we can more effectively pinpoint and resolve issues and lead to improved application reliability and performance. So by leveraging these tools together, you can build a robust observability framework that will keep your serverless application running smoothly. Thanks very much, guys. And if you do have any questions, please fire away. Yeah. I think someone has a hand.
To me? Oh,
yeah.
There was another hand. Thanks, all. I especially liked the demo you did at the end there. I was wondering, okay, so X-Ray has some costs associated with it, like CloudWatch, and if you're doing both, that's extra, right?
Yeah.
It sounds like a no-brainer that you would kind of implement it into whatever you're building, but it probably depends if your architecture is, sufficiently complex. I don't know if you could give maybe some examples of what kind of architectures would you not need to use X-Ray, and at what stage would it be valuable to you?
Yeah, I think when it comes to serverless architectures, it almost always is going to be valuable because, like sort of what we were saying, that the different services involved, you're going to have multiple different components and sort of moving parts. And there's not going to be sort of one obvious point for us to go and have a look at to like diagnose issues. Whereas say if you were just deploying something with like EC2 or maybe even with Fargate, for example, then you've sort of just got that one container that you can just see the logs for. There's not really any need for like tracing if things aren't moving between various different components and services. But when it comes to serverless, I think it's almost always going to be useful to use X-Ray.
Okay, that's a pretty good answer. So basically, anytime you're like a little bit average complexity, that it's useful there.
Yeah. And you can sort of use the sampling rules that I mentioned to sort of mitigate against like ending up running up your bill massively. And it's really not going to end up being a massive cost unless you have it enabled in like a high traffic production environment. So that's really what you got to watch out for.
Okay, that's good to know. Thanks. That's a great answer.
Just quickly, I'm like there's a link in the chat for a lucky draw, and like filling in that short survey, like that's your entry for this lucky draw, and the prize is just a 250 rand take a lot voucher. So if you want to fill that in quickly, like that would be great. If anybody else has questions for Saul,
I do.
yeah, okay.
So like for this example you did present us, like it is very simplistic, but I do debug this on a daily basis just using CloudWatch, and my architecture is just, I just go fetch once at DynamoDB, but I do not see how this will effectively help me. If my logs are set up to a certain extent, how would this? It seems like it's going to cost me money.
Yeah. No, I do see what you mean. I mean, if your architecture is simple enough and you don't find that you're spending ages like trying to find the right log group and whatnot, then maybe it's not for you. But for example, if you do have like more components involved, like for example, I was recently working on a project where we were using API Gateway, Lambda. There was an external call that used not an external call even, but we used a custom Lambda authorizer, for example. It had a AWS WAF in front of the API. So even like at face value, you think, oh, it's just a simple API and I'm just going to make some call to an external service and send the response back through. Pretty quickly, you might end up with sort of more moving parts. And if you've got log groups on your API gateway, you've got log groups on your Lambda, you've got log groups on that custom authorizer Lambda, it might just be a bit of a pain to sort of like go and try and check each of those log groups individually to find where the error is coming from. And especially when you've got that trace ID in the response header, it can just be like really quick to just go straight to X-ray and just paste that in, and immediately you just see in that graphic like where the error comes from. But maybe in simple architecture, it's not for you and you don't need it. That's fine as well.
And then, for instance, if it is high traffic and quite complex, would you just deploy it into production? Would you keep it there?
If it's quite high traffic, then I would suggest like not having it trace every request in production, but instead, like based on the traffic level, you can make one of those custom sampling rules to only trace like a certain percentage, so that if you do have errors, you're gonna hopefully capture those through that sampling. Whereas then in development environments where you're not going to have quite as many requests, it's not going to cost you as much to just trace all of them, so that you can identify like issues while you're developing and moving your deployment up through your development environments.
Cool. Okay. Yeah. Thanks.
Anyone else? Let's wait a few more minutes and for everyone to fill out the survey if you want to. I just have I have a few questions, but let me ask just two. Like you mentioned, the CloudWatch and X-Ray, but have you ever used like third-party tools? And like, would you recommend them, or how do you find the trade-off between these two?
Yeah, so there definitely are plenty of really good third-party tools out there. I'd say the main drawback of those is that they do get expensive quickly. And in my experience, like if you sort of know what you're doing with some of the native AWS services, they're actually really powerful. And we only really looked at CloudWatch logs in this talk, but there's also other parts of CloudWatch like metrics, and you can actually make custom dashboards and stuff like that. So you can actually quickly build up like something that would be quite similar to a third-party tool for like a fraction of the cost. So I would almost always opt for that, unless maybe you have like more non-technical people, or you might be migrating an existing solution that already uses a third-party tool and you just want to provide like a familiar interface. Then like there are good reasons to use those third parties and spend the money on that as well. But yeah, it's just going to be more expensive. So I'd usually opt for the native services if you can.
Okay. And
Leon, if I'm not mistaken, you do your own custom login. You have a service similar to custom login?
and no, I don't have anything, but I wrote a blog like a few years ago, also advocating for AWS services. And then I used Datadog, which, I mean, if your company wants to pay for it, like, let them pay. It does do some very cool stuff. I'm not gonna lie.
Cool.
Yeah. And X-Ray, like, I think I used it about 2 years ago, and then it like seems great on paper until you connect some resources. Like I thought you sent stuff over, I think it was SQS. It just could not track over SQS. I'm not sure if anything changed since then.
Oh, right. Yeah, no, I haven't actually tried personally using it with SQS as much, but having a look through the documentation and stuff, it definitely does say that should be able to do that. So I don't know if that's a recent change or whether the documentation might be telling a bit of a lie there, but I think on paper it should be able to do that.
Yeah, I've used it with SQS in the past and it seems okay. So I don't know if AWS have fixed something recently or.
Yeah, maybe.
There's another question.
Yeah, I have a question for the Josh Turney. So
Sure.
I have a question for the Josh.
Yep.
Yes, correct.
Yeah, this is regarding the first presentation. So what are the consequences we face for the automatic remediation in production environments, and how do you handle this? So I mean, so when we can use it for manually?
Yeah, I mean, if you're working with this in production, I guess just the one consequence you can have is sometimes unintended actions, I suppose. I don't know if I'm provisioning, if we go back to the S3 bucket example, if I'm provisioning an S3 bucket that is public in production, that I want to be public, and I have this automatic remediation config that then changes it to be non-public, that's obviously going to be quite annoying for you as a developer if you're not able to provision it. At the end of the day, it's a trade-off.
But when to use manually?
Sorry, say that again.
So when to use manually? So how do we know?
Yeah, I mean, it will just be a discussion within your organization. I'm sure your organization will have certain things they don't want to happen. Maybe it's a rule within your organization that you don't want any buckets to be public, and that's more or less the norm from what I've seen. And maybe there's a conversation in your organization that's just pulling random examples. While you don't want to block setting your Lambda timeouts to a minute or over a minute, maybe you want to be notified of when this is set. So then you can have a discussion with your developers to determine if this was on purpose or whether this is by accident. So really, you just need to have a discussion between your developers. As like a rule, I guess, anything that is severe or may cause, sort of potential instant damage to your organization, you probably want to have some automatic, remediation, or even potentially blocking the action in the first place with service control policies. If it's something that's not going to have immediate consequences for your organization, but you want to be notified of when it happens, something that's like a moderate severity, then maybe you want to have like some manual intervention with SNS. But yeah, really what it comes down to is just having a conversation in your organization and identifying those things that you want to flag or not.
Yeah, I appreciate that's a good response actually.
Okay. Right. I think let's go to the lucky draw unless there's another question. I don't hope so because we're over time. No questions. Okay. These are the people that filled in the survey. So everybody has a pretty good chance of winning, I think. And now we're going to go to the wheel. So we can spin this. Okay, it's pretty obvious who wins. Tondari, I will contact you with email and send you that Take-A-Lot voucher. Thank you very much. Yeah, it actually makes a sound, but I don't think you can hear it. No.
That's a really great spin. We missed it.
All right. Okay. Well, thank you very much, everyone. It was a great presentation. Thank you, Joss and Saul. I really liked it and learned some stuff. Thank you very much. Yeah, I guess this is it. We stop the recording. Thank you, everyone. Have a nice night.
Thanks,
Thanks,
all.
everyone.
Bye.
Thank you. See you.
Thank you.
Cheers.
Bye.